Yeah, thank you. All right, so so this will give me what? Well, so if I take row 2 and replace it by row 2 minus row 1, so this will give me 1, 0, 0, 1, k, 1. So I get k minus 1, 1 minus k, and then 0 in this case. Yeah, so that would be 0. So 1 minus k squared, 1 minus k, and then you get the 1 minus k here. Okay. So last but not least, let's get rid of the, let's see how do we do, so did I do this right? So I did do it right, but now I have a problem, but I think that fixed that problem. So if I do k squared, so let's see. So let's try to do this now. Okay, so I want to get rid of the 1 minus k squared. How can I do that? I can just make this multiplied by k squared. So let's do row 3. Replace that by, so if I add it, yeah, so row 2 plus k, row 1, row 2, sorry, it should be row 3. And this is 2. Okay, perfect. So 1, 1, k, 1, 0, k minus 1, 1 minus k, 0, 0. So, okay, so this would give me, so 1 minus k squared plus k squared minus 1, right? So that should be, sorry, minus k. So it should be just 1 minus k, I believe. So yeah, so 1 minus k squared minus k squared, sorry, plus k squared minus k. So yeah, so that checks out. And then I guess I get so then for the second, so the third one would get k minus k squared. So 1 plus 1 minus k squared. Sorry, 1 minus k. 1 minus k plus k minus k squared. So I should just get 1 minus k squared. Yeah, perfect. Okay. Yeah. And then so that since that's 0, this is just going to be 1 minus k. Okay, perfect. We're almost there. All right, so now do you know what to do to get rid of that 1 minus k? That's there. This one right here. I can just add it again. I can just do row 3 plus row 2, and then I'll get rid of it. So do row 3 and then row 3 plus row 2 now. And this should just give me 1, 1, 1k, 1, 0, k minus 1, 1 minus k, 0, 0, 0, and then I think so this should be maybe 2 minus k squared, and then 1 minus k. Perfect, right? All right, so now it's in REF form, and now we can start analyzing this, okay? So again, what are the forms that you should look for once you have an REF? When do we have infinite solutions? Like, if you had one of the rows completely what? Yeah, zeros, right? So if k squared, 2 minus k squared is 0 and 1 minus k is 0, then we have infinite solutions. So let's see when that happens. So Okay, so let's do, okay, so 1, let's do this guy right here. So 1 minus k is equal to 0, which implies that k equals 1 would make that part 0. And then 2, this part right here, you get 2 minus k squared equals 0, which if you factor this, this would give me 2 plus k, 1 minus k equals 0, which implies that k has to equal -2 or 1, right? All right, now that you found out when this stuff is 0, when do we have infinite solutions? Remember, meaning when is the bottom going to be completely 0? For what value of k? 1, right? So 1, you have infinite solutions if k is equal to 1. Okay, 2. When do we have no solution? What? When you have a non-zero thing and a 0? Like, sorry, no. Yeah, exactly. For but why? Why? So yeah. So you'll get all zeros, like the left-hand side of that line of the octave one, and then a number. So what that says is that you get a number equals 1. I mean, sorry, you get 0 equals 1, basically, right? And that's not true. So that's why we look for that. So maybe I should make it a little more clear what I mean by this. So I think for you guys, maybe it'll be beneficial if you plug in the k value. So plugging the k value, this is what you get: 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 2 minus 1, 0, 0, right? So you see how this one has 2 free variables, so that means we have infinite solutions for this one. No solution for k is equal to 2 or -2. Why? Well, what do we get? We get 1, 1 minus 2, 1, 0, minus 2, minus 2, so it's minus 3, 1 minus, so it would be 1 plus, so it would be 3, 0, 0, 0, 0, and then you get a minus, a 3 here, right? So this last row right here implies that 0 is equal to 3 if you rewrite the equations, right? So this is that's why this one has no solution. It has infinite solutions if k is equal to 1. It has no solutions if k is equal to -2. Now, when do we have a unique solution? When k is what? Yeah, exactly. Remember, the only way we can have a unique solution is if those two like, I guess, let me color code them. So that purple box and that red box are not 0, right? So if they're not 0, then you can always do a reduction where you make that purple box a 1, and then you get your solution. So that'll make it a unique solution. You'll make it a diagonal matrix, right? So 3. Unique if k is not equal to -2 or 1. Okay. All right. So do you expect something like this to be on the tests? So I mean, the REF stuff I'm going to give you is going to basically look like this, right? Because I mean, if you can use a calculator. If I ask a question, just what is the REF of this thing, then it'd be pointless to me to give you that problem, right? However, you will probably still need to use your calculator just to check like some, stupid stuff like if some matrix multiplication is what you saw it to be, or if you can maybe do like or if I need you to find a solution for a system, and then I need that part for another part in the question. So you can just save time and do RREF and find the solution that way. So you'll still need your calculator. I'm just saying that you'll see something like this. If that wasn't enough information, you will see this on the test, right? Okay. All right. So that was 10. Let's move on to 11. All right, so again, I remember how I told you, I also want to test your conceptual understanding of the stuff we talked about, right? So there will be some true and false questions with a little why part. Now, it won't be like prove it or anything. It'll be like, why is this true or why is this false? So, for example, like this. Does the matrix, matrix equation, let's say AX is equal to 0, always have a solution? Okay, so what do you guys think? Would it always have a solution? Would it sometimes not have a solution? Again, I'm not looking for you to prove it. Just giving like a somewhat like a good explanation of why that may be true or not. Or so a good example is like if you can think of a counter example, it's like, oh well, this one is it's a matrix equation that equals 0, but if you REF it, you have no solution here, or something like that. So you can just if its inverse exists. That's only for that. So that I mean all that means is that you will have a unique solution if it inverse exists, right? Okay, so what's this? I mean, for this to have a solution, it means if you plug something in for x, it works. What's the stupidest thing you can think of that will make it work? 0. Yeah, exactly. Yeah, right. So x equals 0 would literally make this 0, right? So this will always have a solution. So you can just say it like this, like, yeah, for x equals 0. Sorry. So it works for this one, all right? So now think about it. So that doesn't prove that it always has a solution, but think about the REF, okay? What are the only situations that you have no solution? We just did it right now. We analyzed that matrix, right? So when did we have no solution? What made it break? Well, if we look at number 2 right here, what made it break? It made it break if you had like that 3 on the right hand side, right? 0 equals 3, right? Would you ever have that situation arising with this one? No, because the right hand side was always going to be 0. So you'll always either have a unique solution or infinite solutions, but never no solution, okay? So that's how you can explain it. So I guess you can say solution. This is true because it's you can say REF form will always have, I guess you can say, zeros on the constant side of the augmented form. So you will always have. So I guess you will never. I guess you say you will never run into the problem at 0 equals 1, right? So you can just say it like this. Like, I mean, this isn't a proof. It's just literally just explaining, right? Okay. So yeah, so do expect questions like this. So this might be one bullet, this might be one question, and I'll have like parts maybe A through D, and you'll start seeing a bunch of these. So I'm gonna go through more examples like this. I'm not just gonna leave you, but so do study like the concepts, like of what we learn, results kind of thing, right? All right, so let's see, what's another one? Okay, so sorry, I'm trying to think of a good one. Okay, so yes. So is is the following true? I'll upload it on Remind right now, but I'll also send it to through an email just in case some of you guys don't have it, right? Okay, so is the following true or false? So let's say so if uh, if let's say if x equals, let's say, b1 is a solution to the homogeneous system ax equals b, right? Sorry, let's say b equals 0. That's what it means to be homogeneous. And let's say x equals b2 is a solution to, let's say, ax. Let me maybe I should do this to be maybe let me do like alpha here, and let's make this one beta. Equals b, right? Does okay, then again, so we say then a x equals b has infinite solutions. Okay, so this one might be no problem. Good luck. So so something like this, right? So again, would this be true or false? What do you guys think? So again, just think about it like a little bit. So again, I think this would be I think maybe some of the one more tougher questions I might ask, something like this. But again, I mean, if you start drawing some stuff, right? It doesn't matter what you do. Like just start, even if you don't know, always try to get partial, because I always do give partial credit. I don't just like leave you high and dry with like 0 points. If I see that you're trying and at least you're putting stuff that makes sense, I'll always give like enough points where you won't like that you'll be completely out of being able to like not fail this class or fail this test, right? So I will always give you points again to where you can always pass the class even with the homeworks and all that. But do try. Don't just leave the question like blank. Okay. So but for this one, what do you guys think about this one? Would this always does this guy right here have infinite solutions, or is that not true? So first thing I would do is basically this. Say, okay, well, I know that x equals alpha is a solution to that homogeneous matrix thing over there. What does that mean? Again, what does it mean to be a solution? If I plug it in, It gives me that, right? And I know that x equals beta is a solution to ax equals b. And again, what does that mean? It means if I plug in x equals beta, it should give me b, right? So let's use that, okay? So first thing I would do is be like, okay, well, I know this, so let's see. Um, let's say we have, let us have x equals alpha plus beta, something like this, okay? Again, how did I come up with this? Well, I literally, so I'll tell you my how I thought of this. I'm not just gonna like tell you, oh yeah, well this is obvious, so just define it this way. But this is what I was working in my head. So basically, if I was wondering, okay, what happens if I do ax equals, okay, so if I plug in x equals alpha plus beta, what does this give me? A alpha plus beta, right? Okay, now what can I do? I can distribute, right, which would give me A alpha plus A beta. Again, okay, so now, what is this going to equal? So, for example, what is, for example, this guy going to equal? 0, right? Yeah, 0. What about this guy? Well, I mean, it should be there, right? So what should that blue box be? Huh? Yeah, B, which means that this entire thing is going to equal B, right? So do you agree that x equals alpha plus beta is a solution to this guy? I mean, I plugged in alpha plus b and it gave me b, right? So it is a solution to it, right? Okay, so now, what do you think? Will this have I mean, I found one here. So does that mean that I'll have infinite solutions? So what can I do to that alpha plus b? Like, how can I modify it to maybe get another one? Slightly, I guess you can say. What if I don't know, for example, multiplied alpha by some number, 2? Would I still get the same result? Okay, I guess everybody's tired. So, yeah, I'll still get 0, right? Because remember, scalars pull out of matrices. You can pull them out, and you still get 2 times a times alpha, which is 0. So 0 times any number is just going to be 0, right? So you're still going to get 0. So is this going to always work for any number? Like if I plug in 5, for example? Yeah, right? It's going to work. So no matter what number I plug in, it's always going to give me the same solution. But notice that if I modify it by putting a different number in front of that, okay, yeah. Good. I think I should have mentioned that first. So in my head, I was thinking, okay, so I know A times alpha is equal to 0, and I know that A times beta is equal to B, right? That's what I had in my head. So I knew these two things. So I knew from the statement, I knew these two things. Beta is equal to 0, and I knew that A times alpha is equal to B, right? This is what I knew. Then I saw this. I was like, okay, well, what if I add these two together? Well, this would just give me A beta plus A alpha is equal to B again, right? 0 plus B is B, right? So then I just did this. I just factored out the A and it equals B. So I just said, oh well, if this is X, then just give me another. That's how I thought of it, right? That's why I signed X equals alpha plus B plus beta. But again, this will be one of the tougher questions I would ask on the exam. It might be just like a few, like maybe, like I said, um, if you do this review, you should score like an 80, 85, right? I won't deviate from this, and then I think the tougher questions will make up the rest of it. It won't be like this tough. I will like vary it, maybe something like this, right? So maybe this will be the extra stuff that you can get to get the A. But yeah. So that's how I thought of this. Um, so the solution to this is true because you can just say x equals, I don't know, let's say c times alpha plus beta is always a solution to ax equals b for every c for any real number c. Okay. No. No. So alpha was not zero. Alpha is just some vector. If you plug in alpha into a, so like that's, I mean, it's like saying this, right? If you go back to normal, like if I say 2x plus 1 equals, I don't know, 0, and I say x equals negative 1/2 is a solution. I mean, what does that mean? If I plug in x equals negative 1/2 into this, it gives me 0, right? Same thing over here. That's what I mean by this. If x equals alpha is a solution to this, that means if I plug in alpha, I get 0 as a result. Not that doesn't mean that alpha is 0. It just means that whatever that vector is, you don't know what that vector is. It can be non-zero, it can be 0 or whatever. All I know is that if I plug it in, it gives me 0, right? Okay, so yeah, perfect. Uh, so let's now work on something else. Let's go back to, let's say, I don't know. Let's say, so some, I guess, elementary matrices, right? So let's see. So yeah, I guess I guess it is tough. Um, but if you notice, this was actually one of the examples I gave in class. So probably should look through the examples. So this was an example, but yeah. So again, always test your, um, always go back and look at the big picture of the stuff we did, right? Don't be tied down with, do I know how to do this computation? I mean, do them, do practice them. However, also take a step back and then see, okay, what did I learn from this section? Well, the key points were this. If the determinant was non-zero, it means it has an inverse. If it has an inverse, it means it has a unique solution. Stuff like that, right? So always go back and also just take a step back and take a look at the picture. I promise you, if you do that, this entire class just becomes easy. Like it's like nobody like trivial at that point. But it does take time and practice. So always look at the big picture. I mean, if it helps, always just go like, I don't know, like maybe do section, I don't know, section 1.1 and do like key points, right? And then just make yourself some bullet points of whatever, right? Some big picture bullet points and have those in mind, because that would that would guide your thinking in a lot of the problems. Homogeneous, so, oh, okay, so homogeneous, all that means is that it equals 0. That's all it means, okay? At least for y'all's purposes. So if you have a homogeneous matrix equation, just means ax equals 0. That's all you have to know. If it's non-homogeneous, that means it's ax equals b, where b is not 0. Okay. Okay. Okay, so maybe another conceptual problem. If so, is the following true or false? Okay, so is, let's say K1, K2, K3, and let's say that all this stuff over here doesn't matter. Let's just let me just put this as I guess stuff, right? So all that stuff up there just means that it's just not numbers, right? Doesn't matter. Is this invertible? If so, when is it? Sorry, that's not true. False question. So is the matrix is invertible? Okay, so let's take a look at this one. Is this invertible? Okay, so what are your thoughts? So, huh? Yeah, exactly. So yeah, and determinant. Okay, so what's the determinant of this? Okay, but that's good. That's the first good step right there. Okay, so this is again testing your whether you guys knew the key points and pictures from the section. What is special about this matrix here? What do you see that we talked about this kind of matrix before? It's what? It's a triangular. You said? Yeah, exactly. It's upper triangular. What did we say about those kinds of matrices and its determinant? So the determinant of, I guess, well, I guess it can even, I guess, cofactor expand it to even see it. But what do we say about this? Well, the determinant of a upper triangular or lower triangular is just the product of the diagonal. Okay, so what is the determinant here? So recall for a triangular matrix. Yeah, exactly. Yeah. The determinant is the product of the diagonal. Okay. So what's the product? So let's say this is A. So the determinant of A is just going to equal K1, K2, K3. Okay, so now you know this. Is this true? It goes back to what you said. It'll be what? It'll be true. Yes, it'll be true, but only if one of those K1, K2s is not 0, right? If one of those is 0, then it's not, because so true if K1 is not K1, K2, K3 is not 0, right? False otherwise. Okay, perfect. So again, I'm trying to make you guys recall all the things because I know you said, I guess we went a little fast. So I'm trying to recall all the 2 points and stuff. So do remember that the product, the determinant of the upper triangular is the product of the diagonal, okay? And that goes for just a diagonal matrix, right? Diagonal matrix in general, right? Okay. So let's see, what time is it? 45. Okay, so let's do one more conceptual problem. It does. So do you guys know? So if you guys didn't know that, what would be an easy way to check yourself whether or not? I mean, you can just go with a 2 by 2, right? Like 1, 2, 3. Sorry, 0, 0, 2. I mean, what's the determinant of this? Well, the diagonal of this minus 0 times 2, which is just going to be 0. So it's just 2 times 1, which is that diagonal, right? So you can just also always check yourself with examples as well. If you don't know if something's true or false, always do the easiest example and just check yourself, all right? So I guess that's the strategy with true and false questions, right? So a good strategy is to do this. If you don't know if something's true or false, always just check with small examples. That will always basically help you determine at the very least if it's true or false. And then maybe you can, I don't know, BS the explanation or something, right? I mean, that's usually what I would have done. If I didn't know, I was just BS it. I was like, well, it's true because, I don't know, theorem, whatever, right? That's what I would do. But at least if you do it with an example and then say true or false because of that example, I guess I would give a bit of fun. Actually, since it's just let's say if I give it, say it was 10 points, I would give 6 or 7 points if you can do that. Okay. All right. Oh, well, I guess, okay. So let's see. One more. Is the following true? True or false? If, let's say E1 or let's say E are elementary matrices, and let's say that this goes from 1 to n. A is equal to I, then A is invertible. Yeah. Is this true or false? Huh? Yeah, true. Why? Huh? Because it's 0? But, sorry. Yeah, okay, yeah, that's true. I did say that in the theorem. Now, I guess if you can reference the actual number, that's pretty impressive. So I'll give full points so you can say. But okay, so other than the theorem, I did explain somewhat why it was true. So what can you do with this to be sure that this is invertible? So just, I guess, remember another result. Are elementary matrices invertible? Okay. So what can I do to this equation to be sure that this is invertible? So what if I just multiply both sides by the inverses of each elementary matrix? So solution, so yeah, like I said, it's true. Because since elementary matrices sorry, I'm like running out of time, are invertible, that implies that A could equal E1 inverse all the way to En inverse. Now, are the inverses of elementary matrices again invertible? Well, yeah, right, because you just go go backwards. And so then from there you say, okay, well, since that, then the product of invertible matrices again were invertible. So that implies that A is invertible. Okay, so again, so I wanted to basically take this entire class period to review conceptual type problems because I will include that in the exam. So I'll either do true and false and make a statement. And basically how you see me solving them here will be how you answer them, okay? And again, I will give you some of the review that I type out, and I won't deviate too far from the ones that are on the review. So I mean, they're not going to be super new or anything like that. I'll just modify them a little bit, and then see if you can like reason out kind of the same thing I'll do in class. Okay. All right. That'll be all. Any questions, comments, concerns? Oh yeah, probably the the notes. So